Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving an absolute value equation. I don't want to tell you what it is because that would kind of give away what we're going to do. But we have this equation where we're solving for z. Z is a complex number. So the absolute value of z divided by z minus 1 is equal to 2. And we're going to be solving for z values. So we're looking for a number that satisfies this equation. Z is a complex number, like I said before. If you're new to complex numbers, go ahead and check out my lecture videos. I also have another channel that focuses on algebra, number theory, and trigonometry, and it's called Cyber Math. But that's cyber with an S. Great, let's go ahead and see how we can solve a problem like this. To be able to solve this problem, we're basically going to be using substitution, right? And this is going to turn into an interesting equation, which I'll show you. So I'll be presenting two methods. For the first method, let's just go ahead and think about this number right here, z divided by z minus 1, right? And its absolute value is equal to 2. So how is that possible? Well, if we can call z something, that will be meaningful. That's what I mean by substitution. And in this case, we would go with either a plus bi, which is the name of this channel. Hopefully you knew that, right? Or x plus yi. Let's go ahead and use x plus yi. I'm going to go ahead and explain, if I don't forget, towards the end why I choose this one. Now, we have to do this in the numerator and the denominator, so it's going to look like this. X plus yi divided by x plus yi minus 1. And we need to take the absolute value, and this equals 2. Okay? Now let's go ahead and simplify this a little bit. We want to go ahead and bring the real parts together. So it becomes like this, x minus 1 plus yi. And again, I need to take the absolute value. Now, there's a couple different ways to go about it, but I kind of want to take the hard approach first because sometimes you don't know what to do with a problem and you may be picking the hardest method, okay? So that's what I'm going to try to demonstrate. Here, if we go ahead and multiply the top and the bottom by the conjugate, the complex conjugate, which is x minus 1 minus yi, we have to do this here and here. We're going to get something like this, x plus yi multiplied by x minus 1 minus yi. And in the denominator, because you multiply two conjugates, let's think about it this way. If you multiply a plus bi and a minus bi, from difference of two squares, you get sum of two squares. Why? Because I squared is equal to negative 1. Why? Because I is the square root of negative 1. That's how we define it. Okay, when I say the square root, I mean the principal square root of negative 1. Of course, every complex number has 2 square roots, 3 cube roots, 4 fourth roots, so on and so forth, and nth roots, except for 0. Okay? And 0 is not that interesting because you can't even plot it in the complex plane. And even if you plot it as a point, it has no direction, it has no angle or argument, so it's not that interesting. In the denominator, we're going to be getting x minus 1, real part squared, plus the imaginary part squared. Of course, we still need to take the absolute value after we simplify everything. Of course, in the numerator, we need to use distributive property. Let's go ahead and multiply these two things. That gives us x squared minus x. And then the next thing I'm going to do is multiply this one by this one, because they both have I, and I squared is negative 1. So when you multiply those, you're going to get negative y squared I squared, which is going to turn into positive y squared. Make sense? So that way we got the real parts out of the way. Now we're going to go ahead and deal with the imaginary parts. X multiplied by minus yi is going to be minus xyi. And then yi multiplied by this is going to give you plus xyi minus yi. Okay? And then the whole thing is divided by this. And we still need to take the absolute value, right? Absolutely. Now, let's go ahead and simplify this a little bit if we can. First of all, these two are going to cancel out. And then we end up with something like x squared minus x plus y squared minus yi divided by this. and the absolute value of that equals 2. Great. Now let's go ahead and split it up. So our goal is to turn it into a complex number like a plus bi so that we can take the absolute value directly. To do that, we're going to go ahead and split it up into two pieces like this. X squared minus x plus y squared all over this expression right here, and then minus I times, sometimes people will write the a plus bi as a plus ib, which is basically the same thing. And in the trigonometric form or the polar form, we prefer that because cosine theta plus I sine theta looks much better. So when we split it up, we're going to get a minus y here. I put the minus sign here already. And then the denominators are the same. And of course, we still need to take the absolute value. Here we go. So we kind of turn it into something like a plus bi so that we can take the absolute value. But the absolute value, by definition, what is the absolute value of a plus bi? It's the square root of a squared plus b squared. And you'll remember that. That is the square root of the product of a complex number and its complex conjugate, right? So here, to take it, we're going to take the square root of this real part squared, right? This real part squared, and then plus the imaginary part squared. And then of course we need to take the square root of that. So it's going to be y squared here. And then we'll continue. And of course we need to, oops, I meant to do the square root. So it'll be like this. And then I'm going to go ahead and square the whole thing, okay? There you go. And we want this to be 2. We don't need the absolute value symbol anymore because now we have the radical. So far, so good. Now, one thing you can do to get rid of the radical is square both sides. And notice that these two have a common denominator, but it's only after squaring. So it's going to look like this. X squared minus x plus y squared squared plus y squared divided by x plus 1 squared plus y squared, and then you need to square that one more time, okay? And then take the square root of this guy here. But it's going to simplify because this part will basically cancel out the square root, right? Cool. Now, actually, we did take this, sorry, we squared both sides, so this should equal 4. And of course, we don't need to square right symbol anymore. Here we go. So this canceled out as well. Okay, sorry. I probably did too many things in one step. I hope you forgive me for that. But what I did basically was square this, square that. They have a common denominator, which is something squared. But then I take the square root so it cancels out. And then numerator is this squared plus this squared. I hope that makes sense. Okay? And 2 squared is 4. Now, what do you do with this? Okay, we're going to expand and expand, right? Let's go ahead and write it this way first. This squared plus y squared equals 4 times x minus 1 squared plus y squared. Awesome. And then what are you going to do with this, right? You're going to go ahead and expand everything and then put everything on the same side. But you're going to have a lot of issues with the fourth powers, with, you know, so many other things. So you're probably thinking, isn't there an easier way to do this? Yeah, slightly easier way to do it is by using the second method, of course. What is the second method? It is the easier method, okay? So here we go. We're going to start with the same thing with the absolute values, which is z over z minus 1. So it's going to start like this. But then we're going to do something dramatically different, which is first split it up into 2 absolute values, and then multiplying both sides by the absolute value, z minus 1. In other words, cross multiplication. And why do we do that? We don't want to deal with fractions and complex conjugates. Here we go. Now you can go ahead and replace z with x plus yi, and then it should be fairly easy. We have x plus yi here, and then we have the 2 here, and then we have the x minus 1 plus yi. You already know that, right? And now I'm going to go ahead and take the absolute values separately. You see, it's a lot easier to do that way. This would be the square root of x squared plus y squared. This would be a 2. And this would be the square root of x minus 1 squared plus y squared. There you go. So easy, right? Now we're going to go ahead and square both sides, of course. And that'll give us x squared plus y squared equals 4 times x minus 1 squared plus y squared. And I can always expand it, right? To expand it, I'm just going to use the formula. This will be 4 times x squared minus 2x plus 1 plus y squared. And then x squared plus y squared can be written as 4x squared plus 4y squared minus 8x plus 4. We're not done yet. Hang in there because we're almost done. Now we're going to go ahead and put everything on the same side. We're going to bring these here. So that'll be 3x squared plus 3y squared minus 8x plus 4 equals 0, so that everything is on the same side. And then we do need to do something which is going to be helpful. Divide everything by 3, okay? If you do that, you're going to get x squared plus y squared minus 8 over 3x plus 4/3 equals 0. The next thing we're going to do is a common practice, which is called completing the square. Let me go ahead and bring these two things together. So the question is, what should I add to these two terms, so that this becomes a perfect square? And to find it, you just need to look at the coefficient of x, and negative is not that important. This will become 8/3. You're going to divide by 2, which is 4/3. So you need to add 4/3 squared, or 16 over 9 to both sides. But you already have 16 over 9, and then you have the y squared, and then you have the 4/3, and you have the 0, but you just added 16 over 9. Great, no worries. We're going to go ahead and put these things together, like these 3, and then subtract that number, and then end up with y squared. Let me show you how this works. This is x minus 4/3 to the second power plus y squared. And if you subtract 12 over 9 from this, that will be 4 over 9. Now, what does this tell you? If you remember this type of thing, like x minus 8 squared plus y minus k squared equals r squared, is the equation of a circle with center at h, k and radius r. So this is a circle, and we call this a locus problem. That's why we use x plus yi instead of a plus bi, because we want to represent it in the coordinate plane, which means there are infinitely many solutions, and when you draw the circle, all the points on the circle are going to satisfy the original equation. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out Cyber Math and aplusbi, and bye-bye.